Nonlinear SVM Classification. So while the linear support vector machines are quite effective and perform very well in various scenarios, many data sets are far from being linearly separable. If you take a look at this one, if I wanted to separate this data set, right, I would need to draw a circle. So in this trivial example, if you take your space like a piece of paper and you fold it up, you can go ahead and draw a linear classifier that cuts through that space, kind of like a space-time warp travel type thing. And now I can classify nonlinear data by expanding out a dimension. So we can do that through introducing additional features, right? This has 2 features. And this one here has kind of 3 features. So if we introduce more features, we can work with nonlinearities. So let's take a very simple example and see what we can do. Here I have data with a single feature, right? So maybe it's petal length or something, and I've got 2 blue squares, 5 orange diamonds, and 2 blue squares. But if I were able to add a feature, so here let's say that x squared is equal to x1 squared. Now that second feature is completely derived off the first feature. So I'm not going to be adding any information, right? And it's a linear feature, so it'd be easier to take out. But if I add that feature x2 here, now that these 2 things are perfectly linearly separable. So adding features can be a good way to do nonlinear classification. Then when you on-warp your data and bring your data back into a plane, right, or onto your initial plane, you can get streets that look like this. There we go. Right? So this is still a linear classifier. It was just solved for with a support vector machine in a space that had added features. And then I removed those features and I brought it back down to a 2D representation. So the space was all folded up on itself, drew a linear classifier, just like we have here in this image, and then I brought it back down on itself. We can do that in sklearn with pipelines and polynomial feature transformers, followed by a linear SVC, and it's effectively demonstrated here. And this is kind of a classic half moons data. We call it half moons because it looks like a moon. And that's a data set that you can make in sklearn. You can make the data set, you can run polynomial feature transformation, run your linear SVC, and then remove your polynomial features in a pipeline. And that's how you can create nonlinear support vector machine classifications.